Welcome to Pramod Nainapalli YouTube channel. Today we discuss a very important topic, reactivity and orientation of substituents towards electrophilic aromatic substitution reaction. So about the substituents in my previous lecture I have given. So please follow the link which has been shared in the comment box of the the types of substituents. Now we have discussed in the previous class that substituents are of two types, electron donating and electron withdrawing groups. Electron donating groups on benzene ring increases the activity and those groups are called as activating groups. So activating and deactivating groups we have discussed. So activating, deactivating. So activating groups means these are the groups, these are electron donating groups which increases the rate of reaction. Deactivating group means these are electron withdrawing groups which decreases the rate of reaction. Very simple. So what are activating groups? These are the groups which increases the rate of reaction. Which groups they are? Electron donating groups. Yesterday we have discussed the electron donating group means electron donating group, particularly the group like hydroxyl, NH2, methoxy, ethoxy, propoxy, all these groups comes under electron donating groups. Methyl, ethyl, propyl all comes under electron donating groups. Electron withdrawing groups means like groups like halogens, chlorine, bromine, iodine all comes under electron withdrawing groups. Now how does this activating groups increases the rate of electrophilic aromatic reactions? Electrophilic aromatic reaction which will undergo, we know that benzene will undergo electrophilic aromatic substitution reaction. We have discussed the various types of electrophilic aromatic substitution reaction in my previous lectures. So they will undergo electrophilic aromatic reaction, but if there is an activating group, it increases the rate of reaction. How does the activating groups increases the rate of reaction? We are going to discuss. And also these activating groups are ortho or para directors, whereas deactivating groups are meta directors. Means when there is a presence of activating groups or electron donating groups, what happens means the rate of reaction is increased, but electrophile will attack on ortho position or para position. I will give you one example about the activating groups, why they are directors of ortho and para, and how they increases the rate of reaction. These things need to be answered in this particular video so that you get the clarity. Now I consider one group like methyl group. What is this methyl group? Methyl group comes under electron donating group. In electron donating group, it is a weakly electron donating group. So they are weakly electron donating group. So the methyl group which is attached on the benzene group is an electron donating groups. Now electron donating groups are what? They are activating group. They activate and increase the rate of reaction. They activate the benzene. How they activate, I will tell you. Now we know that one of the important step. What is that step? So when this react with, say that I will denote with some other marker, that is Y plus. Y plus say that it is an electrophile. It is a electrophile. Now what happens? What does the reaction takes place? How does the reaction takes place? Let us see this. Now what happens? This will give the electrons. This will give the electrons. Electrophiles are electron deficient. Now what is going to happen here means you can see the things that there is a methyl group. I will write with the blue marker only, just understand. There is a methyl group, okay, and there is a hydrogen. Y is attached here. Since this carbon given the electrons, it carries the positive charge. Okay, so this is formed. This intermediate is formed. You know very well. Now, how does the methyl group activate the benzene and increases the rate of reaction first. So I am writing related to this electrophile is attacking on ortho, because this group is an activating group. Activating group is present means the electrophile will attack only on ortho and para position. Why it will attack on ortho and para position? Why not it will attack on the meta position? We will discuss. Okay, so here what happens? There is a formation of the benzene carbocation. Now this will undergo resonance stabilization. So resonance stabilization structures are very important. So I will write in this form. Okay, resonance stabilization. How to write the resonance stabilization means you have to write in such a manner that the pi electrons move towards the charge and charge will come here. 1 pi electrons. So how does it will happen means the place of the pi bond will go here, this bond remains same, and here methyl group, here hydrogen, here Y. You can see here. What is happening means the this structure will undergo resonance stabilization, whereby the electrons movement of this pi electrons moves towards the charge, and charge will come where the pi electrons are moved. As a result, you get a hybrid structure, resonance hybrid structure. That is how you get means you get that pi bond moves towards the charge, means it will come here. This bond remains same, and positive charge where the pi bond is moving from this carbon. So positive charge will take that particular carbon. So positive charge. So as a result, this is methyl group, and as usual hydrogen and the electrophile. Now the next structure, one bond is moved towards the charge over. So other technique is this will move towards the charge. Another bond is there. So you get another resonance hybrid. Two bonds are there. You get two resonance hybrid structure. So it will come. Suppose this is one first structure. This is second structure, and this moves towards the charge, and the charge moves towards the bond where it is left. Okay, now if you see this clearly, you will understand. So what happens? The pi bond moves towards the charge, and the charge will move where the pi bond has been left. You get another resonance structure, that is you get like this. This pi bond moves, this bond remains same. This moves towards the charge, it comes here. It carries the positive charge H, Y and CH3. Okay, so this are the three important resonance structure of the electrophile attack. So equivalent structure, if you see, the equivalent structure of all these three becomes what means delocalization of pi electrons takes place throughout the ring. That's why we write like this dotted, and dispersal of charge takes place throughout the ring. That's why we write at the center, and here methyl group and hydrogen followed by Y. So this is the equivalent structure for 1, 2, 3. Equivalent structure is this one. Now we have taken this particular structure in all the electrophilic aromatic substitution. We have taken directly this structure and undergone next step. But why activating groups? Why these activating groups will increase the rate of reaction, or how does this activating group increases the rate of reaction means very simple. You can see here, because of this more stable resonance hybrid structure. Structure 1 is more resonance stabilized. Why means the carbon holding positive charge and same carbon holding the electron donating group. So carbon holding positive charge means what? Why activating groups are increases the rate of reaction means because of this more resonance stabilized structure. Structure 1. Why it is more resonance stabilized means the carbon holding the positive charge, same carbon holding electron donating group. So when they are holding electron donating group or activating group, what they do means carbon holding positive charge. Carbon holding positive charge means positive charge indicates what? Positive charge indicates electron deficient. Now what happens? This will give the electrons. Now this will give the electrons to this carbon. As a result, positive charge will go away. For example, very simple. I am there and some poor people, beggar is there. So suppose he want to become a stability, he want per day 300 rupees. If I give 300 rupees, his day will go. Means his his deficiency will go. His deficiency is 300. Now, if I am giving him 300, he becomes more stable. Because he becomes more stable. Same way, what happened directly, the carbon holding positive charge, electron deficient, this electron donating group or activating group releases the electrons and stabilizes by dispersal of this positive charge throughout the ring and movement of electrons throughout the ring by making various resonance structure. That's why what happens, the electrophile which is attacked on the ortho position will be more resonance stabilization than that of meta position. So that's why what happens, the rate of reaction will be increased because the electron donating group or activating group donates the electrons. Since the benzene carries the positive charge, there is an electron deficiency is there. The electron donating group gives the electrons, removes the deficiency. Like this, it is going to stabilize when electrophile is going to attack at ortho position. So this is about the ortho position. Now same electron donating group, if it is attached to the same electron donating group, suppose if it is attached to meta position, why it will not attack to the meta position? I will tell you. So they are only ortho and para director, means electrophile will attack ortho or para if there is a presence of activating group. Why can't they attack on meta position? So this is an ortho position and we have seen. Now this is a meta position to this and this is a para position to this. Now we are talking about electrophile attack on the meta position. So when it gives the electrons, what is going to happen? Why it will not direct at meta position? Now what happens? You can see that here methyl group is there, hydrogen is there, and electrophile is attached. So electrophile will be attached. Where they attach, this gives the electrons. It will attack on the meta position, and when it gives the electron, this becomes positive charge, and there is a double bond as usual. This double bond, this has given the electrons, pi electrons, and formed this particular structure. This will undergo resonance stabilization. When you are writing the resonance stabilization, whichever bond is nearer, first you move the bond towards the charge, and the charge will move towards the where the pi bond has been moved. So as a result, what is going to happen here? You just observe this bond remains same. You just observe this positive charge will go on this carbon. Yes, this pi electrons will come this particular where the positive charge is there. Rest of remains same. Methyl group. It is a very easiest technique. What you have to do means, when electrophile attack on one carbon, the next carbon takes the positive charge. Now they move the electrons either clockwise direction or anti-clockwise direction. Now pi electrons are moved here and positive charge will be moved on this where the pi electrons are left. You get one resonance structure. Similarly, the other, this is the first structure, this is another hybrid structure. Now what happens? Again, now this bond is over. Now this bond will move towards the charge and charge will move towards where the bond left. So what you get there? You get another resonance structure. This will be moved here and this structure, one bond will remain the same. Here you get methyl group. Okay, and what happens when it is moving here? The positive charge is taken here. Now what happens? If you see, you get a equivalent structure. Even here also you get a equivalent structure if you take, but they are not resonance stabilized. Why they are not resonance stabilized means, you see all the structure, first structure, second structure and third structure. Do you have any structure like first structure here? First structure is what? In case of ortho director, the electrophile is attacked on the ortho position. The carbon holding positive charge, same carbon holding the methyl group or the activating group. Any resonance stabilized structure is there? No. This structure is there? No. The carbon holding positive charge, same carbon holding methyl group. This structure is there? No. So what happens? This is not there and this is not there and even this is also not there. Like a first structure of the ortho director, means when electrophile attack on the ortho position, because it is more resonance stabilized. So such kind of a structure we cannot find in the meta position. That's why this particular activating groups are only ortho and para directors, not the meta directors. So they will not, electrophile will not attack when activating group is present. Electrophile will not attack on the meta position. It will attack only on the ortho para, because it gives more resonance stabilized structure. This is about ortho and this is about meta. So why meta is not possible means it will not form a more resonance stabilization. When more resonance stabilized structure is not formed, the rate of reaction will not increase. The reaction is very slow, hence they will not direct towards the meta position. So this is about ortho and meta. Now when you take, let us see about para position. When electrophile attack on the particular para position means this is an activating group. Okay, so this is ortho position, this is meta position, this is para position. Now what happens if this is a para position? This will give the electrons. This will give the electrons in order to attack on the para position. Now what happens? The carbon having hydrogen and the Y will be attached here. Means Y is nothing but electrophile. Now electrophile will attack on the para position. Now when it is attack on the para position, which is given electron? This pi bond is given electrons. So what happens? It becomes electrodeficient, carries the positive charge. The positive charge on electrophile is shifted on this carbon because it has given the electrons. That carbon has given the electrons. It is formed a first structure, and this will undergo resonance stabilization. When you are writing the resonance stabilization, very simple trick that move the pi electrons towards the charge, and the charge must move where the pi electrons have been left. Now what happens when you do like this? This pi bond will come here and this positive charge will go here. Just you concentrate that structure. This pi bond remains as such. So you get the resonance hybrid structure number 2. And from here, now this pi bond is over. Another pi bond is there. Move this pi bond towards the charge, and the charge will come move towards where the pi bond has been left. Okay, so a very simple way, wherever it is moving, the pi bonds will move either clockwise direction or anti-clockwise direction. They move either in the clockwise direction or anti-clockwise direction. Same way that the charge will move either clockwise direction or anti-clockwise direction. Very simple. Pi bond will move towards the charge and the charge will come here. You get another resonance hybrid. This is the technique of writing the resonance structure. So equivalent structure, they will form throughout the ring. Dispersal of positive charge will take place. Delocalization of pi electrons will take place. Now you compare the resonance hybrid structure of para position and ortho position. One structure is very important. I said the carbon holding positive charge and same carbon must hold the activating group. Is there any structure? You see this structure is not there. But if you see this structure, structure number 2, carbon holding positive charge, same carbon holding electron activating group. Yes, there is more resonance stabilized structure is present in case of para position. In case of meta position, this type of structure is not there. Even in case of ortho position, this type of structure is there. Ortho and para position, there is a carbon holding positive charge and same carbon holding activating group will make it more resonance stabilization. When it make more resonance stabilization, it will get more activated. The ring will activate, cause the dispersal of charge very easily. As a result, what happens? The distribution of charge will take place. It will become more and more resonance stabilization, increases the rate of reaction. So only ortho and para position electrophile will direct when there is a presence of activating group. They will orient either ortho position or para position. They will not orient meta position, because meta position will not give more resonance stabilization structure which has been formed in the ortho position, ortho substitution or ortho director or para director. Which structure that is? Carbon holding the positive charge, same carbon holding the electron donating, so that it will donate very easily. Very simple thing. When you are nearby your friend, if you want to give the money to him, you will give directly very easily. If he is far away, it is very difficult to give. So carbon holding the positive charge means your friend is near and he is having deficiency of money. You are giving money means what happens? You will become more stable near. If he is in a far away, okay, that will not be stable. You cannot give very effectively to your friend because he is far away from you. So it is very difficult to give the money to him. So it will not, you will not be stabilized because he will be in resonance. He will be in particularly he will be in deficiency. Same way what happened? Carbon holding positive charge, same carbon holding electron donating group. It gives the electrons and cause the dispersal of charge throughout the ring and cause the dispersal of charge throughout the ring, pi electrons throughout the ring. Any resonance structure which cause dispersal of charge and dispersal of pi electrons will become more stable, and more stable will increase the rate of reaction. This is all about the activating groups. So now let us discuss about deactivating groups. What are these deactivating groups? We have already discussed electron withdrawing groups, which decreases the rate of reaction. I have taken one example, that is electron donating as a chlorine. Okay, chlorine is in a deactivating group. First we have to answer why it is in a deactivating group. Why it is deactivating group means when electrophile is attacking on ortho position. Why it will not attack on ortho and para? It is only the meta director. Why it is only the meta director, I will tell you. But first you see the ortho position as well as the meta and para, then we will understand the things. First question is that why this electron withdrawing groups are deactivating group means, now when electrophile attack on ortho position, what happens? This will give the electrons, this will give the electrons. As a result, what happens? Y will come and attack here, H. Next carbon takes the positive charge. Now this is the first resonance stabilized structure. This is a structure, and this will undergo other resonance stabilization structure. Means the pi bond moves towards the charge and the charge will come here. You get the second resonance structure. And third resonance structure, what happens? The third resonance structure, pi bond will move towards the charge and charge will move towards the pi bond left. So you get the third structure. So this is 1, 2, 3. Why they are a deactivating group means carbon holding positive charge, same carbon holding electron withdrawing group. Carbon holding positive charge means what? Carbon holding positive charge means electron deficient. And once again what happens? Chlorine draws the electrons more and more. As a result, positive charge will not disperse. Positive charge will remain the same. Positive charge remains same means it will be localized. Localized means what is the meaning of localization? It will not disperse. Why it will not disperse means already carbon holding positive charge is an electron deficient. Again what happens? Again this chlorine will withdraw the electrons. When chlorine will withdraw the electrons, what happens? The positive charge will be localized. It becomes more and more electron deficient. Now for example, first of all the beggar is there. Beggar is having 100 rupees. If I go and take that 100 rupees also, what is going to happen? You will become more and more beggar. You will not be stable. First of all, he is a beggar, he don't have money. Again you are going and taking money from the beggar. So, same way what happens? First of all, the carbon holding positive charge is an electron deficient. So again electron withdrawing group chlorine will draw the electrons. As a result, the positive charge will not disperse. As a result, the beggar will not go because the 100 rupees also has been taken away. As a result, he will be unstable. He will remain there only. He will not move anywhere. If he have money, he will move somewhere else to eat or drink. Same way what happens? Positive charge will not move further. It will not undergo stabilization. That's why what happens? Because of this first structure, they will not attack on the ortho position. It becomes more unstable, more and more unstable. They will cause the deactivating of the ring, decreases the rate of reaction. So ortho position is not possible because of the first structure. it becomes more unstable. It makes more unstable, whereas activating group makes the more stable the ring, increases the rate of reaction. But deactivating group destabilizes the ring by withdrawing the electrons, thereby what happens, decreases the reaction. Now meta position, I have written same. This when it react with at meta position, this is a meta position. When it attack the meta position, I have written here resonance structure. So what happens, the electrons are given by this. As a result, hydrogen, this, they are given by this. So what happens, when it is given, the positive charge is shifted to the next carbon. Whenever the electrophile will attack on the particular position, blindly you keep the positive charge on the next carbon. They will also undergo resonance stabilization. This will move towards the positive charge, and positive charge will move towards the pi bond where it is left. As a result, you get a second structure. This is the first structure, this is the second structure, this is the third structure. So what happens, this moves towards the positive charge move towards the pi bond. As a result, you get second structure. Same way what happens, this pi bond or pi electrons move towards the charge, and the charge will move where the pi bond has been left. You get the third structure. But why they are meta directors? Deactivating groups are meta directors means you see that carbon holding positive charge, same carbon holding the electron withdrawing group, any like that first structure in ortho position, like that structure is there here? No. Any structure is there? No. So first structure is highly destabilized. Such kind of a structure is not available in meta position. That's why when deactivating groups are there, electron donating withdrawing groups are there, meta position is possible, because destabilization will be more if carbon holding positive charge, same carbon holding electron withdrawing group. This type of structure is not available in the meta position. That's why it is somewhat stable, but they are deactivating. So they are only the meta director, not the para director. Now when same will react at the electrophile attack on para position, what happens? The next carbon takes the positive charge. Here it will take the positive charge. The pi bond will move here, and positive charge will move. You get second hybrid structure. Same way what happens? Another one, positive charge will move towards the pi electrons move towards the charge, and charge will come here. You get the third hybrid structure. So what happens among 1, 2, 3? Do you have most unstable structure like ortho position? Number 1, where carbon holding positive charge and chlorine. In case of para position, yes, here structure 2 you are having carbon holding positive charge, same carbon holding chlorine. That's why they will not direct at para position also, because they are highly unstable. The rate of reaction will be decreased. Even meta position is also unstable, but it is somewhat okay. That's why the electrophile will attack meta position if there is the presence of deactivating group. So deactivating groups are there means they direct only meta position, because the structure like resonance structure like carbon holding positive charge, same carbon holding the electron withdrawing is not present in the meta position. That's why they will direct on the meta position, not at the ortho position, not at the para position. So this is what electrophilic aromatic substitution reaction. So what happens, activating groups, they will direct ortho and para position, because they will form a more resonance structure at ortho and para position. Okay, and they increases the rate of reaction. Whereas deactivating group, they are the meta directors. They get deactivated because it increases the it makes destabilization of ring. When it makes destabilization of ring, the rate of reaction decreases. Activating group increases the stability, deactivating group decreases the stability. Due to decrease in the stability, the rate of reaction is decreased. In case of activating, increase in the stability, by donating the electrons, they will increase the rate of reaction. This is all about reactivity and orientation of substituents towards electrophilic aromatic substitution reaction. Thank you.